Okay, here I'd like to continue the discussion of the Cisco ONS 15454 system, and here I'm moving into what is Chapter 11 of the Configuration Guide. And in this chapter we've got a whole long list of cards, and it's a very long chapter if you've looked through this thing. Let me go up here to the top though and give you the basic idea. We've got TXP and MXP cards are the basic two types of cards, and the MXPs, well, they all take what are optical signals from client interfaces and turn them into what are called trunk signals, which are part of the DWDM wavelength system. So typically these optical client signals, they call them gray optical client signals because they're in some sense colorless. They're maybe at 850 or 1310, maybe at 1550, but they could be at any wavelength essentially. And you need to be able to take that optical signal and put it onto the DWDM system. And these cards are sitting between what are called the client interfaces and the DWDM optical interfaces. Okay, so these go both ways in that capacity of sitting between these two. So the MXPs generally handle client signals. They aggregate, multiplex, and send them over to a higher rate port. So this is a multiplexing functionality. It may be taking multiple OC3s and turning them into an OC12 on a SONET system, for example. And so these client interface signals are generally going to be something like a SONET optical signal. It also demultiplexes optical signals coming in on a trunk and sends them out to the individual client ports. So it goes both ways. The TXP convert a single client signal to a single trunk signal and convert a single trunk signal to a single client signal. Okay, so the TXPs sit between the clients and the trunks, the DWDM trunks, with a signal, a one-to-one signal correspondence, and the MXPs sit at the same interface but handle multiplexing and demultiplexing functionalities. Okay, and then they say a bunch of these cards, the GEXP, the 10GEXP, etc., can be provisioned as either TXPs or MXPs or layer 2 switches. So these are very sophisticated cards, and these form the heart of the system. They all perform OEO conversion, so they're all very expensive, and basically I'll go ahead and show you. I'm not going to try to even begin to cover all these different kinds of cards, but I'll show you the list of the cards here in the card summary. The list goes on for another whole page, and some of the newer ones are the 10GEs, the 40s, 40 gigabit DWDM channels, and 10 gigabit DWDM channels. So what I will do though is start with the very first card, the TXP MR10G card, or one of the very first cards. Yeah, this is the first card in the list. It processes one 10 gigabit signal on the client side into one 10 gigabit signal on the trunk side, which is on one of the 100 gigahertz DWDM channel wavelengths. It provides one 10 gig port on the per card that can be provisioned for an OC192 short reach signal. And so this is a SONET signal. Okay, and we're taking a SONET signal on an incoming wavelength and putting it onto one of the DWDM wavelengths. Okay, it tells you here which slots you can put them into. And the interesting part here, well, we've got the picture of the faceplate, but the interesting part is this block diagram, which shows the card sort of plugged into the backplane. All of these cards plug into the backplane in the chassis. and it shows that we have the client interface, an optical transceiver, taking an optical signal in, turning it into an electrical signal, and here we're doing framing, forward error correction, and DWDM. Well, we're doing essentially the 3R type of thing: retime, reshape, regenerate. Okay. I'm not sure that we'd always do retiming here, but we're certainly reshaping and regenerating when we go to a new optical transceiver. And this optical transceiver then is at one of the DWDM wavelengths in particular. Okay. And so that's what you've got here in this chapter. Is you've got this giant long list of these things, of these different cards which do different things. Here is, for example, skipping up to page 11-17 in table 11-3, showing a whole list of different client interfaces and their bit rates, and whether we're doing 2R or 3R regeneration as we take these client interfaces and move them off into a 1550 DWDM wavelength. So we have OC48s and STM16s. These are SONET signals at 2.5 gigabits per second. We're going to do complete 3R regeneration here. We've got DV6000 signals. I think that's a video signal. We're only doing 2R regeneration there. Fiber channel, high definition TV, gigabit Ethernet, gigabit fiber channel, OC12 and OC3. These are more SONET signals. Okay. The OC3 is 155 megabits per second, essentially three T1, essentially three T3 lines, and OC12 is essentially 4 OC3 lines. For the SDH systems, it's called STM1 and STM4. SCON, more video. Some of these things I don't even know what they are. But these are examples of the different types of client interface signals we're going to see here. Okay. You know, as I say, I'm not even going to try to go through all of these different cards in this chapter. The chapter is 300 or 400 pages long. Let's see, why did I print out this page? Here's a 40G, 40E, 40ME cards, aggregating a variety of client service inputs, GigE, fiber channel, and OC192 into a single 40 gigabits signal on the trunk side. Wow. Okay, so we have these 40 gigabit signals on the trunk side. So a lot of the DWDM channels are operating at 40 gigabits. These 40G cards are fairly far down the list in the original summary of all the cards. The 40G cards are here. The further down, usually, the newer they are, and so 40G is you know, it's pretty good feat to put 40 gigabit per second on an optical fiber, and that's because the requirements on keeping dispersion low are extremely stringent here in a 40G system. Okay. And this shows sort of an end-to-end picture of taking a client signal all the way to another client signal. Here we have a client signal coming into an MXP card, a 40G MXP card, and it turns that client signal into a DWDM trunk signal, a wavelength, one of the channel wavelengths in the 1550. If you go ahead and put MXP cards in the middle, here what you're doing is a 3R regeneration on most signal types. And then you can go to another DWDM system. The reason you would do this is that you've gone as far as you can with that 40 gig channel. That's a very fast channel. It's an OC768, I believe, if we were doing SONET speeds. And the fiber optic link there can only go so far if we're operating at 40G due to dispersion effects, as you know. And so here we do a complete regeneration, go on to a new DWDM system, and finally break it out to a client system again. So this shows sort of an end-to-end configuration where we have a regeneration, an OEO regeneration in the middle. And really that's all I'm going to say about these cards in Chapter 11. It's a huge long chapter, and there's a huge variety of these cards and lots of information on them. So, thank you.